The purpose of this lab is to determine the limiting reactant by comparing the amount of reactants used to the height of the precipitate created. We need to understand the basics of stoichiometry, which is the study of quantitative relationships between reactants and products, and the definition of a limiting reactant, which is the reactant that is consumed first.
A quick example of stoichiometry would be a recipe that requires 2 breads and 1 slice of cheese to produce 1 sandwich. If you are given 6 slices of bread and 4 slices of cheese, the bread would be the limiting reactant because the bread would run out first before the cheese, according to the recipe. You would only be able to produce 3 sandwiches with 1 slice of cheese left over.
In the lab, we filled up 8 test tubes with 5 milliliters of copper sulfate, and then we increased the amount of potassium hydroxide by 1 milliliter for each test tube, which was a clear liquid. We then filled up each test tube with water so that the overall height is 13 milliliters for each test tube.
In addition, the amount of precipitate levels off in test tubes 5 through 8. The precipitate in all the test tubes was the same, a blue solid foam-like substance. Since copper sulfate is a constant amount throughout, the precipitate is increasing when we add more KOH in test tubes 1 through 4, so we can assume it is a limiting reactant and is making the changes. In test tubes 6 through 8, since copper sulfate is also constant throughout and the precipitate is not changing, you know KOH isn't contributing anymore to the reaction, so we can assume copper sulfate is the limiting reactant and is making the change.
In test tube 5, there is no limiting reactant because both reactants are equally used. There are many possible errors that may have happened during the lab. For example, in many labs, the burette got clogged with bubbles. In addition, people may have mistaken the burette measurements.